Welcome to the next exercise. So I have this basic drawing on the right hand side of the screen, and this is basically a revolved command which we have to use over here, and we have to create the geometry which is seen on the screen. That is the geometry C. So this is a circular shape or a mechanical component. We have to understand the procedure for creating it, and we have to analyze the geometry given to us. So let me maximize at first. And what you can see on the screen is that we have a revolution. We have a sketch over here that is basically I section. It is revolved around the central axis. We have the dimensions mentioned. That means the width of the I section, that is 34 and 64 respectively, and we have the distances of the positions of each segment with respect to the central axis. Now the difference between the previous revolution commands what we have seen and this particular exercise is the location of the sketch. So far we have seen the different ways of creating the revolve geometries, and whatever we were creating, we were locating or placing the sketch on the central axis. But in this particular case, the sketch or the closed loop has to be placed at some distance from the central axis. The reason for that is because of the hole which is seen over here. So if you are trying to cut this geometry laterally, the section what you will be finding is the I section. Clear? So we are trying to create the I section and we are revolving it around the central axis. But this I section is placed at some particular distance from the central axis. So let me just minimize it. I'll just show you the example what we have to do right now. We have to place, imagine this is the kind of section, okay. We have to place it at some particular distance, because if we are placing the section at some particular distance from the central axis, then only we will be able to form the hole like feature in the total component. Clear? I'll just show you. You can see over here, we have a hole over here. So we are trying to create something similar to this way. And let me show you another example where I am placing the geometry on the axis. So in this particular case, I will not be getting any hole because the sketch is in contact with the axis and it is sweeping itself. You can see over here, it is sweeping itself and it is creating a feature or a component. So we have to follow this particular thing, that is to place the section at certain distance from the base. So let us try working on it. I'll just close this thing. And let me go to revolve command, select the front view or the front plane and align the plane to the normal view. Now I can work on it. So there are two things in this geometry. First thing is I have to place the sketch above the horizontal axis. Clear? So as we have decided that the horizontal axis is the axis of revolution, we have to consider this sketch above the horizontal axis. That is the first thing. The second thing is the symmetry, which is the vertical symmetry. Okay. So if you are observing the I section, it is symmetric on both the sides. That means the kind of distances the feature is having on the left hand side of the vertical axis is quite similar or exact to the distances which are on the right hand side. So I can utilize the vertical axis as well for maintaining a symmetry in my geometry. So in order to do that, let me click on the central line. And then let me start creating the section. Now I have the distances mentioned over here with a symbol that is representing the diameter. So the first distance is equal to 50 units, and that is the distance of the central, that is the diameter which is present and that is the diameter of the hole what we are having over here, that is 50 units. Clear? And we have to see that this base of the section has to be placed at this particular distance. So let us try to do it, because we are working, we can understand practically rather than listening. So first I have clicked on center line, click on the line segment and see that it is symmetric on the right hand side. So we have created the base right now. So we have to see that it is equal to 50 units. For that, let me click on the datum line. Let me use the global line, because let me assign the horizontal axis to be the axis of revolution. Now the moment I have assigned it, I am getting a dimension over here, that is 182. I have to change it to 50 units. Clear? Because this is the diameter of the hole and the distance of the base of the eye section is placed at a location of 50 units of diameter. So let me change the vertical or the horizontal distance, and that is equal to 64 units, which is present over here on the top. Now let me try to work on the eye section. So what I will be doing over here is we can utilize the mirror command. So for utilization of mirror command, we have to see that we create a segment or a sketch on one side of the axis, and after we are confirmed with the sketch, we can use the mirror command and we can mirror the total sketch on the right hand side. So right now I will be creating the sketch on the left hand side of the vertical axis. Then I will be using the mirror command and I will be copying the total sketch on the right hand side. So let me work on it. So I have to create the vertical line. The thickness of this segment is not mentioned over here, but we have the thickness or the diameter given to us, that is equal to 80 units. So we can just click on the dimension, click on this edge, click on the center line, and again click on the edge to get the dimensions in diametric form. And the dimension is equal to 80 units as per the given sketch. I have changed the dimensions. Now let me create the horizontal line up to a certain distance. Now I have this 34 units given to me, which is the thickness. So I have to follow the same procedure of creating the dimension, that is 1 to 1 I call it generally. This is the first, this is the second, and this is the first again, and press the middle click. So with this technique we will be getting the distance or the dimension with respect to the other side of the axis of symmetry. So the dimension over here has to be 34 units. Now we can move forward or we can move ahead and change the diameter again to be 138 unit. So follow the same technique, but we can observe over here that we are automatically getting the dimension. So we can just change the dimension to be 138.71. And now let me just move on the left hand side. So this distance will be equal on both the sides, that is the upper and the lower sides. So I have to stop my cursor at a position where I'm getting a symbol of equal constraint. You can see on the screen it is visible. So I'm stopping over here. So this will ensure an equal dimension or equal distance. Now I can just move forward and I can stop my cursor to get another dimension, and that is seen on the left hand side of the picture, which is equal to 174.706. Now I can simply connect it to the vertical axis. Now that I have created the sections which are on the left hand side, I can use the mirror command and move them on the right hand side, which we have already seen in the 2D sketching. For that I need to press Ctrl and select the segments which have to be mirrored. As the base is already present on the right hand side, I will not be selecting the base. I have selected the remaining segments. Now click on the mirror command and select the central line. You got the total line segments, but maybe this was not selected. So let me use the mirror command again by selecting it, clicking on mirror and the central axis. So the moment I have selected the central axis, I got a closed loop. Now the only task left for me is to revolve it. So I have to press OK, and automatically it has revolved because I have already created a central horizontal line using the global datum. So I have the revolve geometry right now, and it has swept itself for 360 degrees. Now we can see that the cross section, that is the I section, has been revolved. In similar fashion, maybe you can practice with different form of sections like C section or J section. So these are all the mechanical components. Now we have one task left to us, that is to create the keyhole or the key slot, and it is basically created, or it is in the form of rectangle. So we can try to use the extrude command and we can remove the material at that particular location. So I have to see that, or I have to find out what is the dimension of the width and what is the location with respect to the central axis. So as I mentioned that we have to use the extrude command, we can either click on the central plane and click on extrude command, or we can click on the surface and we can click on the extrude command. It is totally the user's choice, that is your choice. But if you are using the central axis, you have to use the symmetry option for extruding on both the sides whenever you're removing the material. If you are using the surface option for extruding, you have to see that your extrusion is on the other side to remove the material. So I'll just try to show you the difference between them. Extrude. I'm just following a random dimension so that you can understand what I'm trying to tell you over here. Imagine this is the rectangle, and I have created this rectangle in the central plane. So what I'm trying to tell you is, if we are using the central plane, we have to use a symmetry option and remove the material on both the sides. Clear? We cannot work by using the blind option because this will be either on the right hand side or on the left hand side. So we have to use the symmetry option in this case. Whereas if I am using the surface option for creating the extrude, which I will be doing right now, I have to extrude on the one side of the plane. So before that, let me just change the display settings so that you can clearly see it. So I have not practiced this sketch before. I have not ensured that the dimensions are correct. Let me just work on it live and see whether these are correct. So most probably this will be correct. So anyways, let me create the central line for maintaining a symmetry. And now I can use the corner rectangle and place the rectangle symmetric with respect to the vertical axis. So anyhow, my task is to remove the material, right? So I should not be bothered about this dimension, that is the width of the rectangle or the breadth, because there is no material in this particular region because it is a hole itself. We have to be bothered about this region and we have to see what dimension is given to us. The first dimension is the width of the total, or the length of the total rectangle, that is equal to 16 in this case, and the location is with respect to the base and the central axis. So I have to click over here and click on the base and generate the dimension, and the dimension is equal to 29.3. So I have considered both the dimensions which is given to us. So I need not be bothered about the total height, because whatever height I'm keeping, anyhow there is no material in the center. Nothing has to be removed. So I have to be bothered about the 16 units and the location, that is 29.3. I can press OK. In this case, I cannot be using symmetry. I have to use the blind option and change the side, and also I have to utilize the option called remove material. So I'm removing the material in this way, and I have to press the OK command. So this is the way to create this particular mechanical component, which was having an eye section swept around the central axis, and we had a removal of material. So in this way we have also practiced I have not removed the material till up to the next surface. This is better. So we have also practiced the extrude command again, and let us move to the next exercise.